Hello everyone and welcome to lecture in our data structure and algorithm series. I am Dr. Mangesh Joshi from Department of Mechanical Engineering. In today's video lecture, we are going to learn about counting sort, a unique algorithm that does not rely on comparisons like we have seen various algorithms in previous video lectures. So it's highly efficient for specific use cases, especially when sorting integers with the known range, right? So without wasting time, let's begin with the counting sort. So counting sort is a non-comparison based sorting algorithm. If the question is asked that differentiate between different types of algorithm, then counting sort is non-comparison based sorting algorithm that works efficiently for sorting integers. This is the second differentiating point. When the range of possible values is known and not significantly larger than number of elements. So you must be knowing that it is starting from 1 to 10 or 15 likewise. So values must be in integers and ranges of values are known in advance. So it works really well when we know the ranges of values in advance and that range is not significantly larger than number of elements. So main idea in this algorithm is to count the frequency of each unique element and then use that information to determine the correct position of each element in sorted array. So basically what it does, it just counts the number of occurrences of each unique element and uses that count to determine the correct position in sorted array. So what it will does, it will count. This is for example, let's say this array. So it will count how many times 1 is appearing. So at 0 position, as there is no 0, 0 element is present for 0 times. Then 1 element is present on for 2 times. Then element number 2 is present once. So in this way it counts the frequencies. So if you think of distributing test papers into labeled boxes according to the scores. So each box represents a score. For example, if you are counting how many students have received full out of full marks and you have started putting 100 out of 100 test papers in that box. So it will resemble the same situation, right? So you just count how many students got each score, each unique score. Then you collect paper from the boxes in order. That is counting sort. So let us understand step by step how this count sort works. So first step is to find the maximum value in the input array. Why this is required? Because we need to know the range, right? So once you find the maximum value, so you must be knowing that maximum value in the array is 15. So you will basically understand the range, that is 0 to 15. Right. Second step is to create a count array to store frequency of each value, as I have just explained in this example. Third step, modify the count array such that each element at index I contains the sum of previous counts. Next step, build the output array using the count array to place the elements in correct positions. Then copy the sorted output back to the original array if sorting in place is needed. Otherwise, you can keep original array different and sorted array different. So with numerical example, let us understand the key concepts. So suppose this is the input array given by the user 230232. Now next step is counting step. We are counting basically how many times 0 is appearing. So 0 is appearing for one time. Then 1 is appearing for 0 times. Then 2 is appearing for 3 times. Then there is no 4 as the maximum value. We will check the maximum value is 3. So we will check how many times 3 is appearing. So 3 is appearing for 2 times. Once you know the maximum value in the array, you can run this for loop from 0 to that maximum value, and you can initiate counting based on the value of I and j. So we need to create count array to count occurrences of each number. So result after counting is 1. So count array will be 1, 0, 3 and 2, right? Then third step is reconstruction step. Now you know that 0 is appearing once. So I will put, while reconstructing it, I will put 0 one time. So since 1 is not appearing, the frequency of which it is 0. So I will not write that. I will skip that part. Then 2 is appearing 3 times. So I will run a loop which will run for 3 times and it will add 2 to that array. Then 3 is appearing 2 times. So finally 3 and 3. So this is the sorted array which you will get after implementing this counting sort. So to implement it perfectly, you will require an array of integers which you need to sort. Then count array to store frequency and position information. Then output array to build the sorted version. And logic for cumulative counts to determine positions. So this is the counting sort algorithm implementation in C language. So here maximum value is given 4. So array size is 4. So whatever steps I have just explained, this is programmed. You type this program in any online compiler or turbo compiler and just check whether it is giving you correct sequence, right? So there are rebuilding logic, counting logic, right? So you need to initialize count to 0. Here it is done. Counting array, sorted array, likewise. So you just read each and every step. You already know how each and every statement works, how for loop works, how printf works. So it is already taught to you. In case of queries, you can comment. If you do not understand any part of the code, you can comment. So lastly, pros and cons. In this, time complexity is n plus k. Very, very efficient for small ranges. Then it is not based on comparisons, hence it is faster. The sorting is stable. preserves the order of equal elements. Even if any elements are repeating, then the order is preserved. It then coming to cons, it only works for integers or any discrete values. This is the major drawback. Requires extra space for count and output array storage. It is not suitable for very large ranges, especially if the range is significantly larger than the number of elements in the array. Right? So these are the pros and cons of count sort. Finally, coming to the conclusion. So we have seen how it works, how count sort works, when to use it, and how to implement it efficiently. Remember, this counting sort is a great when your data fits the right conditions. Which are these conditions? Your array must be an integer within the known and manageable range, right? So I hope you understand this count sort. In the next lecture, we will move on to another efficient sorting technique like merge sort, heap sort. So thank you for watching this video lecture and feel free to reach out with any questions. If you are liking these videos, please subscribe. Have a nice day.